All right, hi everyone. We're going to talk a bit about audio basics in Macs to kick off our last section of the course. So we're going to be talking just about digital audio and how to get started with digital audio in Macs. So in Macs, originally digital audio along with digital video processing used to be separate software packages. Not all computers could run digital audio natively on the processor. You needed extra add-ons, so it made sense to break apart the software and sell it in the parts that people needed. That part of Macs was originally called MSP, Max Signal Processing. Now with Macs, you get that as part of the basic package, and all modern computers have been able to run digital audio natively for a while now. I'm telling you this because this is how the documentation is organized in Macs, and some objects in the help and reference and different things will reference MSP. So we'll see that in a little bit. So what we want to keep in mind with digital audio is that when audio is being played or recorded on a computer system, the system is concerned or working with a series of numbers that represent amplitude values. These values are played or recorded at a regular rate. We call that the sampling rate. Although numbers are stored as integers, ones and zeros to be exact, the number of ones and zeros you have to represent this number make up the bit resolution of the audio, which goes to the quality of accuracy of the sampling. So if you haven't worked with digital audio before in terms of the terms and understand the system, there's very good reference material in Macs. If you go to Home, then MSP for that part of Macs, and the tutorials, there's an introduction to how digital audio works. And this is very good. You don't have to go all the way through, but this describes what a waveform is, what is happening, how sounds combine, a little bit of acoustics, and goes through into the analog to digital recording chain and vice versa, digital to analog for playback, and some limitations. So this is very good help. I recommend this. You don't have to read all of this, but especially things like the system, digital representation of sound would be useful in these helps. So for us in Macs, we need to check some things to make sure that Macs is processing audio the way we think. Unlike most applications, your audio hardware setup for listening is not going to be in the preferences for Macs. It's in options, and this is historical. It's always been here before these things kind of became standardized. And so you come down under options to audio status, and then a window pops up, shows you driver, input output device, sampling rate, vector size. So let's just talk a little bit about this. The driver is a software extension. On the Macintosh, it's always going to be Core Audio. For Windows, it's either going to be MME for Microsoft Multimedia Engine, or it may be Direct Sound, depending on the audio system you have in your computer. So if you're not hearing anything with MME, try Direct Sound if you're on Windows. We're not going to worry about input for now, but output is the actual thing we're listening to. Click this arrow, you can see, for instance, that say MacBook Pro speakers, if I was playing. Mac separates the headphones from the speakers as separate devices. So I have headphones plugged into my laptop right now. That's why they're showing up, but the speakers still show up. So Macs doesn't know if you plug in headphones that you by default want to switch your audio from speakers to headphones. You have to tell it. I have a lot of other options. I have a hardware interface, my monitor, and this USB microphone that I use for these videos, and I monitor output through it, or some software. Soundflower on the Mac is a software interface that allows audio to be sent from one application to another, and that's how I record the audio for these videos. So I'm picking the Soundflower. Generally, you're going to pick your speakers or an audio interface if you have it. The sampling rate is generally going to be with the system. Just going to switch to 48. Not that this matters too much, but it matches with the video sampling rate for the video I'm making. I/O and signal vector size have to do with performance. Generally, if your computer starts to get sluggish while doing your audio patches, you'd want to make these values bigger, especially the signal vector size, but probably won't have to do too much to change these. But just know that this is where you're going to find your interface information, and you want to make sure the output device is what you are listening to so that Max is sending audio to that spot. All right, let's move to patching and just show some basic differences between what we've been doing and what we're now going to do with digital audio. So we've been handling MIDI, everything via MIDI to some external software synthesizer. So we've been working at a control rate. And so let me unlock this patch so I can show some things. And I'm just using hide and show on lock. So I can change this now so this shows up. Make everything show up when I lock it. Okay. So with MIDI, at least for the patch within Max, things are only being computed when an event happens. Like the Metro sends a bang message, so random computes a random number. Sends that, addition adds. In between notes, nothing's happening. And with MIDI, in between the note on and the note off, nothing is happening from make note. So we can stop that, go back into editing. And this is an example of control rate. This is happening when it needs to and at a slower rate than we'd expect for digital audio. So the audio rate is happening at the sampling rate, consistent. That's faster. We need to have a way to see when audio is being sent so that Max understands it has to process that at the sampling rate. So here we go. We're going to add in a Max object. Audio objects have a tilde after the name. Looks like a little sine wave representation. In this case, I want to add a sawtooth oscillator. Generates a waveform that is amplitude over time, looks like a sawtooth. Give it an argument for frequency. And then to hear digital audio, I need to make sure I have a digital to analog converter in Max to send that information. So there's two objects. There's a DAC tilde, digital to analog converter, and there's an easy DAC tilde. And I'm going to use the easy DAC in class because it is an interface element that lets you turn it on and off by clicking on it. So if I, in a locked patch, click on the speaker icon, audio turns on or turns off. So I'm going to connect the output of the sawtooth oscillator to the easy DAC, and you can see the patch cords are different. Over here, I've got standard gray patch cords or whatever color I want to assign, but they're solid. Here they're alternating colors. I call them bumblebees. By default, they're yellow and black alternating. You can assign them any color, but just the yellow part will change. The black will still stay there, so they'll still be alternating colors. That's the signal that this is audio rate messaging. So whatever's coming out of the saw tilde object is coming out 44,000, or I change it to 48,000 times a second for each channel. So I lock. Before I turn this on, I'm going to turn down my volume, which over here in the lower right corner, there's an audio meter gain. So now when I click the speaker, I hear sound, the output of the sawtooth oscillator. And when I click speaker again, turn it off, that sound stops because the processing is stopped. The speaker really controls not just sending sound to my output, but it's controlling whether the computing is taking place within the software. Just one last thing, I'm going to open, patch back up. I'm going to delete these patch cords. Raise this up, and I'm going to add one more object. Live.gain. Live.gain, live is a set of objects. Or live is Ableton Live, digital audio workstation software. Max for Live creates a set of plugins that you can use within that software. And live.objects are objects that work within those plugins. So live.gain is a signal level meter and gain control, much like this down here in the bottom right. So I'm going to connect the output of my sawtooth oscillator to the live.gain, and then to the speaker, lock the patch. I can pull this down, and now I have this control within the patch, within something I can grab before the output. That's always a good. This is like adding a master fader in your recording projects or any electronic music project you do in a DAW. So this kind of combination is always going to be there for me. So that's all I've got for this. I'm going to stop here. And next time we're going to dive into playlists, which will play audio files inside of Max and which we can manipulate in different ways. Bye.